This presentation is delivered by the Stanford Center for Professional Development.
Welcome to Engineering and Climate Change, EE 292H. We're excited. We have really important and exciting lecturers today, guest lecturers. As you know, purpose of the class is to help you make a difference, but one very important, simple thing you can do today, vote. It's easy. It makes a big difference. A lot of the other things you could do are harder. Here's what's ahead or what's behind. We've covered at this point most of these topics. And here is this week's lecture, Linda Yates and Ann Edminster. They'll speak to us about green building and kind of beyond LEED for homes. The following week, Dave Duff will talk about modular engineering, electric cars, oh so much more. Our logistics are, as always, you can reach me, my email. We start taping right about now. Please use Courseworks for homework. Anybody who's having problems, as always, you can go ahead and email to me. Don't worry. Just don't worry. Just do the homework and it'll all get counted. There are some great readings on the site, and some of you have taken me up, it's wonderful, on suggesting terrific readings of your own. Thank you. I think the best way, rather than trying to weave all of those into the lecture here, I will start posting all those on the site so you can all get at them and see what these extra readings are. To auditors, let me know if you want me to email you that same listing, because that might be helpful. The videos of the class, you know the usual way to get it, but you know we've got a wrinkle right now, so more about that on the next page. And we've had a couple students over the last couple weeks take us up on meeting in bites before class for lunch. Sometimes the guest lecturer can do that. More often than not, but if I know somebody will be there, I'll be there. And it's fun. If you can do it, it's fun. So, the class, last week's lecture. I know I got a flood of emails from people who couldn't view it, and my apologies. What happened, if you're listening now, but you weren't there or you couldn't hear then, we had a lecturer who gave us some really exciting information about the work he's doing in electrochemical research, especially going towards making fuels. It was really cool. Unfortunately, some of it he's in the middle of patenting. And if he had said that we could go ahead and put all that out on the web publicly, it would have blown his rights for foreign filing. That's how that works. So within Stanford, it's okay, but externally, it's not. So for 2 weeks, last week and this week, our entire class has gone dark to the outside world. I'm sorry, auditors. And the students can get to it by this route. Michelle Lucas tells me. You just go through this route. If you're in SCPD, you have a different arrangement that you know through SCPD. But if you're a regular student in this class, full-time, matriculated, this is your route. I will put the slides on our course site later today, so you'll be able to catch that. You don't have to furiously write it all now. If you have a problem, let me know. And do catch up on Will Chua's lecture this week if you haven't already, because after this week, his lecture gets pulled down off our site, off even this access, and then we'll go back to being public, more available. So, and his lecture will be gone. So you've got one more week to see his lecture. And then your homework each week, and you guys are doing great on this. Summarizing the lecture by Wednesday or sometimes a day or two later. And by Sunday, doing some reading and emailing me at least one burning question. Our lecturers love this, by the way. They know what you're thinking about. They build part of their talk around what on earth is it that the students really want to know about. So keep doing that, please. For next week, here's some readings. Again, the GCEP site is a great place to find some things about advanced transportation options and about batteries. This will be great preparation for Dave Duff's talk. I've been asking for you to suggest a reading, meeting, lecture, or researcher, and a lot of you have come through and done that. As I say, I'll compile that on the coursework site, That's fantastic. You're making us all better informed. I love that. Did anybody decide to take me up on this offer? This invitation to do a quick term project? This is the right place in the quarter to think about that before that end of the quarter madness. Anybody? Just dying to get up here and talk for 2 or 3 minutes about something you passionately care about in climate? Okay, fine. I understand overload. It's too bad, though. It would be neat. Okay. I will not ask again. I will stop being boring on that. But you'd have fun. Okay. Next week, our lecturer, Dave Duff, and he also worked at Park before he worked at Tesla Motors. So right now, he's the senior mechanical engineer at Tesla Motors. He is, or a senior mechanical engineer, his job is to obsess about connections to batteries. That is his job. He does it well. He has a more varied past at Park, and some of what he talked about last year included modular engineering and including new printing processes for solar cell grid lines, which sounds interesting. His goal really is to build cool stuff, and that's what he does. So anybody mechanically inclined, you know, when you're putting together your questions, you can include, it'd be nice if it's environment related, but you can certainly include knowing that that's his place of joy, and he would delight to tell you all about that. As usual, we've got our information opportunities, Stanford nearby. The thing to highlight here is that the Clean Tech Open is this week. So if you're interested in going, this is the time to know. Rex was saying that you could get a discount to go, that the students could get a discount, but time is growing short. And now, without further ado, we're going to introduce this week's guest lecturers, Linda and Ann. And this is a phenomenal project. I'll be interested to hear what you think about this as a field trip versus this as a classroom lecture. We've done this twice as a field trip. The logistics become tough because then we need to find basically a 3-hour window for everybody to be able to get off campus there and come back. But it's been wonderful as well. You can see this beautiful model that they had of what they were doing. And they have really tried to hit a number of important areas in building not just the materials and the design and the eco-sensibility of energy consumption, but water. I'm continuing to be struck by using every drop 4 times. And so there's going to be a lot to learn here. Let's welcome our guests.
Hello, everybody. I'm going to try to get this on and see if this works.
And I will turn this over. Well, don't worry about me. I shift around as needed.
Thank you. So as Leslie said, we've always done this as a field trip because there's just something about not having to use a Mac to actually show the house. This worked a second ago. Hit an escape. Should be doing view full screen. Let's see. File view. Sorry. Oh, there it goes. Yeah. Hang on. The view full screen.
How did you know?
I did. I hit escape and then I hit again. It's still not. Oh. Oh. You rock. Perfect. Great. All right. Well, welcome. We're thrilled to see all of you. As Leslie said, I'm Linda Yates, and the homeowner, not that home. And this is Ann Edminster. And we like to describe Ann as our green goddess, or our guru of green, or our den mother of green. We founded, if I go back, Tah.Mah.Lah is what we call the project. I'll give you a little history. We're gonna walk through this presentation fairly quickly. Again, normally when we do this on site at the house, walking through where you can touch and see it, and it's a really 3D experience. I will tell all of you that on November 16th, I don't know if any of you know this, but the U.S. Green Business Council, which obviously owns the whole LEED standards, of which Anne actually was the co-chair of the development of all of the LEED for home standards. So if anything you want to know about LEED, Anne is really the guru on that topic as it moved from LEED new construction, which is really targeted towards commercial, to LEED for homes. But USGBC has green builds. So any of you who are interested in green building ought to go take a tour up to San Francisco because their international conference is being held in San Francisco this year, the 14th, 15th, and 16th. And on 16th, our house is going to be a featured tour. And I think it runs from 2:30 to...
It'll be on site from 3 to 5.
They'll be on site from 3 to 5. Any of you who would actually like to tag on to that tour after this and come see it for real, you're more than welcome. You're also more than welcome at any time to email any of us because we're one of these people where you'll see that the home is really meant to be a gathering place. And so, for instance, right now I'm mentoring the solar decathlon team at Stanford. It's the first, I don't know if any of you are familiar with it, but those guys have been at the house a lot. And it's one of these things where once you come, you're part of the family. We're like the Hotel California. You can check in, but you can never leave. So you're welcome anytime. The more, the merrier. So let's talk a little bit about where this happens, because it's not just about green building. It's about place, and it's about people. So the property in Portola Valley where we built is actually where I grew up. My parents bought the place in 1967. This is the original house that was on the property. It was actually built as a spec house, and by the time we bought it from my parents, who moved about a mile away, it literally disappeared. So, yeah, this is not...
It's up.
Oh, it's up, okay. Yeah, exactly. So when so historically, my husband and I have done a lot of stuff. Our backgrounds actually are not in green building. I did investment banking, and then I did management, global strategy consulting all over the world. But philanthropically, our huge passion is the environment, climate change, biodiversity. E.O. Wilson is a huge hero of mine. Conservation, wildlife. And so when we decided that we were going to take it and we need to take the house down, what we decided we wanted to do was to really put our money where our mouth was, if you will, and build hopefully what would be the greenest house in America. We actually say it's the greenest house in its class because the greenest house would actually be a yurt or a tent. It would not be what we built. But we wanted to do it as a demonstration site to really showcase what was possible in green building, and to do a lot of other things, which we'll talk about. So that's really where we started. And hopefully this is actually going to... I don't know why this is not going to be functional, but it has to actually work. Mm-hmm. All right, Leslie. All right, any other ideas? Here comes the other idea. Oh, perfect. All right, great. So obviously, we talk about kind of we're happiest when we're hiking, so build us a tent and we'd be happy. So these are actually some of the images that the architect started with. But I'm going to let Anne say a couple of seconds about, so why even should we be building green, Anne?
Oh, well, Linda's got the stats up there, and you guys probably know that. I imagine Leslie's talked to you a lot about the fact that buildings are responsible for a huge amount of the environmental impacts globally. So, and then we break that down by non-residential buildings, residential buildings, new construction, existing construction, the construction process itself, and then operations and maintenance. So there are many aspects to this. We also look at transportation impacts associated with our use of buildings and our choice of building sites. So when we look at through all those different lenses at building impacts, we start to realize that buildings and the way we use them have a very, very large role in our overall impact picture and climate change in particular. So,
yeah, and I mean it's interesting. I mean the largest, Leslie mentioned water, but the largest consumer of electricity in any municipality is actually water. So it's really interesting to see kind of what the major impacts are. So one of the things that's really important about green building, and if any of you end up being architects, or any of you end up going and building something yourself, or think about even if it's remodeling an apartment or building a house or doing whatever, the place you have to start is with the people. You have to start with what you care about, with what your values are. And it's not just about building a structure, because if you just build a structure, then what you end up with is something that has no meaning, has no life, has no imagination. And so really, Paul, my husband, Paul Holland, who's at Foundation Capital, unfortunately, he would love to be here today, but he's kind of doing another talk at the World Bank on just this topic. But we actually went away and said, okay, we're going to start with themes. What do we want the house to be? What do we want it to feel like? What do we want it to do? And so we started with 6 themes. The first was a gathering place. So in my family, I'm the oldest of 5, Paul's the youngest of 4. Everything we do is large and crazy. We do nothing small and intimate. You have to go to somebody else's house for that. That's what you think I'm kidding when I say you're all invited? It's completely true. Ask Anne. She's been there 1,000 times. We've had tons and tons of events. So again, we wanted to make it a demonstration site, and we wanted to have it be a place where we could hold events that would have impact. So whether it is supporting people that hopefully you will vote for today, or it is supporting, or if it is, we hosted an event for Amory Levins. Do any of you guys know who Amory Levins is? Rocky Mountain Institute. The very first event we hosted was a salon for him with 200 people trying to raise funds for Rocky Mountain Institute. The Sustainable Silicon Valley, which is a consortia of businesses and municipalities. We hosted an event for them. There were 5 mayors looking at green building code who were at that event. So one of the things that we'll get a ding on in the house is it's not 2,500 square feet. And Anne will talk about that if a house is bigger than 2,500 square feet, you actually lose points. You start in the hole. For every 100 feet, you are over 2,500 square feet. So a gathering place, we'll come back up, was number 1. Secondly, outside in. So as I said, we're happiest when we're hiking. We said build us a tent, we'll be happy. If you come and you see the house, it has a lot more impact than me just talking about outside in. But the goal is it's all one story. Not only are you no more than 5 feet from being able to see outside, you're no more than 5 feet from being able to get outside. So there's a lot of movement in and out. It also has a huge impact on the concept of integrated design, because you can't really have a house that's outside in if you start with an architect and then 2 years later you bring in a landscape architect. So this whole concept of integrated design, which Anne will talk about in a second, is a big deal. The global sensibility. So Paul and I have been really blessed. We've traveled around the world. We lived in Amsterdam for almost 3 years. The idea here was, look, we do not want to have anything that was strip mined in somebody else's backyard. We don't want chemicals that were made someplace else. We don't want copper that's leaching off a roof into the microbial soils that will then have an impact on people going forward. Multi-generational was really, look, there are castles that have built that have existed for 1,000 years. We build houses for 25. And not only do we build houses for 25 years, we build 4 dwelling places for every 1 person. Just imagine the amount of embodied energy that goes into all of those dwelling places. So our goal was really 2 things. One is to utilize the elements of universal design so that you could have a place that people could be comfortable and safe from 2 years old to 200 years old. And multi-generational also meant that something that it would last forever. And what that, in terms of both kind of the durability aspects of it, but also in terms of the aesthetics. So it's very simple aesthetics, because if you have an avocado green house that was great in the 70s and it's built for 100 years, but in the 80s everybody hates it, then they pull that down. And then you've basically destroyed that. And then obviously a sense of soul was a big deal for us. Our goal was to have it be inspirational and not intimidating. And the biggest piece, and this is what we're going to go into obviously, is the environmentally regenerative piece. So I'm just going to skip through these just because I don't want to take up a lot of time, because we want to spend a lot of time working in Q&A with you guys. So obviously the main part of what Anne and I want to talk about today is this whole concept of being environmentally regenerative. So what does that mean to you guys? What is the concept? You hear the word green, you hear the word sustainable, you hear the word regenerative. what does that mean anything to you guys? And if it does, kind of just shout out what it is that you think environmentally regenerative would mean. No what?
No waste.
No
Net
waste?
That kind of that like cradle to cradle, whatever you use eventually goes back in exactly the same quality.
Yep, cradle to cradle is a great example. Bill McDonough was one of our very first kind of inspirations. We were at a TED conference, and when we were way before we ever started about thinking about building green, and we heard Bill talk, and then we went back the next year and he talked again, and we thought, we were now at that point. So he was pretty inspirational in that whole concept of the cradle to cradle. Any other thoughts? Any thoughts about what the key, so waste, you named one of them. There's really 5 key elements around in the concept of green building that Anne and the gurus that we brought on board really taught us about. What do you think the 5 areas, waste being one of them, what would be 4 others that you would think of? Energy, yep.
Water.
And by the way, energy trumps everything. Water, waste.
Land use.
2 more.
Land use. Land use.
Yep, habitat. And then there's one more.
Air quality.
Air quality, indoor air quality is a key piece of it. It's how would you build, in the way we looked at it, it's...
Occupant health and well-being.
Right.
Yeah.
And that, so the last one is materials. So we really looked at all 5 of those things: energy, water, waste, materials, and habitat. And our goal really, there's actually up here afterwards, if anybody wants to see it, we actually have aerial photos back to 1949 of the site. And we actually brought in 5 field biologists to help us look at the site and to chronicle the native flora and the native fauna. And our goal was really to really turn the slides green so that they would look green. Was really to help restore the land as if it were 200 years ago. So the name Tah.Mah.Lah, because we don't want it to be about us, it's really about no house can make a difference. It's just, we hope that it'll be a pebble in the pond and have a ripple effect. Tah.Mah.Lah is actually the Ohlone word for mountain lion. Mountain lions are the largest mammals that still exist other than humans in Portola Valley. And it's really us paying homage to those people who frankly stewarded the land much better than any of us ever can or ever will. But this gives you a sense of, this is 1949, and then this was in 2000, I think this is 2005. You can just see how different the land was. It was originally basically oak savanna, but then as more and more people moved in and planted non-natives, you could see that growing up. The change is taking place. Okay, so now we're going to get into what are kind of the green goals and features of So when we got started, there are a couple of overarching themes that we were trying to do, and then we're going to get into the details of the energy, water, waste, materials, habitat. The first is that we were really trying to debunk the myths of green building, and there are 3 primary myths. One is that it's ugly, and you have to live in a concrete box with no windows. Well, you're lucky, because you guys are at Stanford, and there are a lot of green buildings, regenerative buildings, that are on Stanford that aren't ugly and aren't concrete boxes. But that really is one of the big myths that you'll hear from people. The second is that you have to drastically change your lifestyle. And in fact, if the questions that you sent us, are those people in this room or those people across? Yeah.
Well, there's some who were probably attending remotely, but
okay.
From this class.
Okay, great. So there's some really great questions in there, and we'll do the Q&A afterwards. But one of the questions, a couple of questions touched on, well, how much do you guys have to really drastically change your lifestyle? And I think the beauty of green building now is that it is fundamentally different. And you don't have to, if you do a lot of the integrated design work that we did, you don't have to drastically change your lifestyle. And then the third myth is that it's twice as expensive. So green building is all about, building in general is all about your tastes and what kind of materials that you want, or what do you want it to look like, or what size it is, et cetera. The increase due to green building is really only 2 to 5%. And I'll give you an equation that Amory Levins shared with me, which is why this is true. So there's really 4, you have to calculate 4 things. One is, what are those things that you are going to do because you are building green that you wouldn't otherwise do? So putting on solar panels. But of course now we've moved from solar panels to solar power, so even that isn't a capital cost. So there are those things that you're going to do and that you wouldn't otherwise do. But then you have to subtract from that those things that you would do if you that you don't have to do because you're building green. So for instance, we don't have any HVAC. We don't have all this ducting all over the place. So that is something you have to subtract out. The third is there are those things that you're going to put in that you're going to put a greener version of. So you're putting windows in anyway. You're just going to put a greener version of those windows in. And right now, until we get to scale economies, there are some of those things are more expensive. And then the fourth thing are the operating costs, which you have basically zero operating costs. We used almost no heat. One of Amory's challenges to us was to design a house that not only doesn't use no air conditioning, which of course you know in this area you don't need, but we use no heat. So that's a big deal. So really, right now, for our project, the increase due to green building was really about 2 to 5%.
So when I was listening to you talk about your project, it seems so much more expensive because you're doing all of this, having environmental consultants come in, and I imagine you're doing a lot more of the pre-building, thinking and inspection than most other buildings, and that didn't add to your cost?
That is a brilliant observation, and we do disconnect those two things.
Okay.
So there are the design costs that we made the conscious choice to boil the ocean. I mean, it took us 6 months to design the floor because we tried all sorts of different things, and we had warm floors who wouldn't disclose what the glues were in it, et cetera. So yes, but we don't really count that because for the most part, most people, we're now at a point in history where you don't have to do all the things that we did, right? Remember, we started 2008, we started designing. We broke ground in 2010 and then moved in July of 2012. The world has come, even in 5 years, a long way. And we really were trying to boil the ocean in a way that most people don't have to do because we wanted to use it as a demonstration site.
Yeah,
Would you agree with that?
One thing to keep in mind is there's building, there's green building, and then there's prototyping. And in prototyping, nobody expects that to be at the same cost as a steady state type of normal production process, whether we're talking about widgets, silicon chips, or houses. So this was definitely prototyping.
Right. So debunking the myths was the first kind of global goal. I'm going to let Anne talk a little bit about the second was demonstrating the power of integrated design.
Yeah, so first of all, have you guys heard the term integrated design? One or two of you? Okay, so do you have a sense of what that means?
You're kind of looking at all aspects of how the building's going to be used in the future in addition to just...
That's part of it. Other thoughts about integrated design? What are we integrating?
All the systems of the building.
Everything.
All the six, and how does that happen?
So you don't just look at the windows by themselves and then look at the HVAC system. You look at the windows and the HVAC, and then decide
Yeah.
how you can.
So who's doing that?
All of the contractors together.
Not just all the contractors, but all the design team and the contractors. So there are actually two terms that we play with. One is integrated design, and one is integrated project delivery. Now, there's a really important distinction between these two, and you can probably guess from the terms what's the difference. Integrated design, integrated project delivery.
Construction versus design.
Right. One is all about design. And those of us in the design community, you guys are all going to be engineers, right? It's all about design, right? Well, no. The thing has to get built. And so the progression from thinking integrated design will solve all our problems to the recognition that, oh, right, then there's all the stuff that happens after design. And in reality, we find we need construction, intelligence, and insight during design. We also need design intelligence and insight during construction, because much as we would like to believe that the design is complete when the shovel hits the soil, it's not. Those 6 months on the floor, that was after construction started, when we kind of went, there are one or two issues here that we haven't quite worked through. And is that the exception or is it the rule? It's the rule. Yeah, absolutely. This is real life. And that is, as much as we try to commit the design to paper, these two-dimensional objects do a rather incomplete job of conveying the three-dimensional reality and the process by which the three-dimensional reality comes into being. So we were progressing in our understanding about this and our treatment of it. And there are a couple of really important things, I think. Again, first, this distinction is, no, it's not all about design, and we need everyone involved, right down to the tradespeople who are going to be executing the effort. Because if we don't understand, if we don't have the benefit of what they know, then we can't create intelligent designs. Our designs, and this is where the classic conflict between the architect and the general contractor come about. Oh, those architects, they don't know anything, they're completely impractical, and frankly, you engineers aren't much better. And then the other side of those contractors, they're just, a bunch of, knuckle draggers, and what do they know anyway? I've been dealing with this for 35 years, and you're both right. We all need to listen to each other more effectively. So the key piece is people. But what's really interesting about this too, and something that I've been thinking about more and more over the last couple of years, is that when I come in and I work with project teams, and usually they are very design focused initially, later move into construction, there is this immediate focus on the artifact. What do we have to do to this house to make it green? What are we going to do to this? What kind of mechanical system are we going to put in it? What are we going to make the floor of? How are we going to frame it? What is going to be that system that provides the good indoor air quality? This is all about the artifact. But the reality is that in order for us to produce this artifact, what needs to happen first? Imagine you guys have all been out in practice for 10 years, and somebody comes in and says, we're going to do the greenest project we've ever done. What's the first thing you need to do?
How many of you have taken classes in the D school?
So what do you need to do?
That's your next class. Design thinking, human-centered design.
What was that? Empathize.
Yeah.
That doesn't hurt. What is the result of empathizing?
Figuring out what the real problems are.
Right. So thinking, what happens? There's a word for that. I'll give you a hint. It starts with L. And it's not loser. What happens? What are you doing? You're in school right now. What are you doing here? Learning. Right? Learning, right? Okay, so in order to produce this new artifact that's greener than one you've ever done before, you need to learn something new. Because you've been engaged in practice for how many years, and you know how to do it. Well, guess what? You don't know anymore. You don't know how to do it, you don't know who to do it with, and you don't know what to do it with. So green building is fundamentally about change. So you need to learn how to be effective agents for change. That is your first job in green building. And integrated design, integrated project delivery means working with your colleagues in a way you have never worked with them before, and you don't know how to do it. You don't know what that process looks like.
And that's why it's a metaphor. Green building is really a metaphor for a lot of the stuff that you guys are doing in terms of product design, engineering. It's all about collaboration. It's about multidisciplinary teams coming together. There's really you could care less about green building, and it would be an incredible metaphor for what you guys are all doing here at Stanford in general, and in whatever life you're headed towards.
Yeah.
It really is the concept of integrated design, multidisciplinary approaches, problem solving, critical thinking, human-centered design, empathizing.
Yeah, I saw a survey on LinkedIn the other day, and it was, are you involved in using collaboration tools online? So I answered the survey, and then a few days later, because I participated in the survey, I got the response back. And it said only 36% of respondents were involved in using online collaboration tools, Well, with your era, it's going to be 100%. And this is one of the things that we are learning, is we need to collaborate more effectively. So we'll come back, I'm sure.
Debunking the myths, integrated design. The third was obviously earning certifications for credibility to raise awareness. So again, we call the house a beyond LEED house. We were not interested in using a bunch of checklists. I have another binder here that does have all the checklists for those of you who are interested in seeing them. There's LEED, there's Build It Green, which is Green Point rated. There's the one that we really used is a one. How many of you have heard of Living Building Challenge? So Living Building Challenge is actually much harder than LEED, and that's really what we used as the core. There are a lot of people, and there's a lot of questions, and we're going to come back to your questions on the checklists and whether or not LEED is actually credible or not credible. Is it too easy? What's the story? Here was our decision, and there are actually buildings on campus at Stanford, and Stanford has said they don't really believe in LEED, and there are a lot of people who are critical of LEED. Here was our logic in why we actually were trying to support a lot of these different checklists, because we are eco geeks. We're totally willing to kind of boil the ocean. There are a lot of people who aren't, who need something to hang on to, and that's what these checklists do. These checklists mean that at least the people who have the right intentions but might not have the inclination to really go deep and go do all their own research have something to hang on to. So what we want to do is use them and push them and get LEED to be better, and the only way you can do that is if you actually leverage them. Living Building Challenge is interesting. It's new. It sits on top of LEED. Why Living Building Challenge is important is because they actually have a set of red listed items. So whereas LEED, you can use things like isonine, which is the blow-in spray foam. You can't use that if you are going for Living Building Challenge because it's made with halogenated flame retardants. So we had to go out and find an insulation that wasn't made with halogenated flame retardants. Oh, by the way, we had an added benefit because that insulation, if they deconstruct the house, the isonine sticks to everything, so it's a lot more labor intensive to try to reuse if somebody ever took our house down, whereas the other stuff is a blown in. It's like a fiberglass, but it feels more like cotton. Again, if you come to the house, I've got whole bales of the stuff that I'm happy to let you do. So that was the third big area. Okay, come back. This is really screwy here. It works fine everywhere else. I love the magic man who comes from the outside. What is it? Why is it? Okay. All right. Okay. So here's another huge thing that we really care about. One of our big overarching goals is to help create a market for green goods. There are 8 different startups that are represented in the house. And again, if you're there, you'll see it. Clean tech is not dead, okay? Despite Solyndra, despite what the media said, it is not dead. It is still an incredible opportunity for all of you guys to pursue, okay? So we basically have Sunrun did our solar. That's this whole movement, the shift from solar power, from solar panels to solar power, right? Which is removing the cost completely. There's no cash down. There's no more excuse. I don't know if you guys know this statistic, but the sun sends to the earth in a single day enough energy to power the whole world for a year. Our problem is not energy, it's the storage of energy. So if you really want to make $1 billion, go out and figure out how to do it in something other than lead acid batteries. So Sunrun, but there's more out there, but Sunrun's the most successful. Zakato is produces the light engines. We have no incandescents in the house, 100% LEDs or CFLs. Sirius Energy produced the windows. We have Sirius windows. Again, you can see those. CalStar Products, green cement company. They do bricks and pavers, etc. Does anybody know what the production of cement represents X% of the carbon emissions in the world? Do you know what that number is?
5.
Higher.
8%?
8%. 8% of carbon emissions from the production of Portland cement. It's outrageous. We have 50 to 70% of the concrete that is in our house is offset with slag and fly ash. Silver Spring Networks is, hopefully you guys will have heard about Silver Spring, but they do the smart meters. Tygo provides energy boost it's an efficiency booster for the solar panels, and then control 4 is the dashboard for the house. The other one, which is an older company but is very interesting, is this company Delta Bluegrass. So one of the things we asked is, okay, if you can do a native grass sod, why can't you do a native grass sod roof? Why can't you do a native grass landscape? And the reason is because native grasses are really woody, and so if you have kids and you run across them, they're not very comfortable to run across. But it turns out that the California Department of Transportation and the California Department of Water, because they're all concerned about water more than energy, have been contract growing. So we joined with them and helped fund the R&D for a native grass sod. There's now 4 mixes. It's 80% less water and no chemicals. So that's another one of the startups.
And great on bare feet. Linda, while you're there, do you want to address some of the questions about smart homes? Or do you want to
Yeah,
come back
we're almost
to that?
done. So I think we should.
Okay.
Okay, let's go through this. And I swear this is like so bizarre. Why is this? All right.
Voila.
And then one of the other big things was grading the construction process. And Ann, do you want to touch on that?
Okay, sure. What do you have up there?
Just the deconstructing and the
ton
offset.
of things. Yeah, so there was an existing house, and I think something like 97% of that house was taken apart and reused in some fashion. Some small fraction was recycled. A lot of it was used on site in various ways. And I think, you know, one of the big stories too relates to the Portland cement. There was a really interesting process that we went through to analyze how to design the foundation so as to use the least amount of energy and produce the least amount of carbon. And our structural engineer initially had a foundation system in mind and designed, and then later said, you know, there was more hauling of soil involved in that process than the alternative. And so he revisited that question, and when he took into account all of the hauling of soil, turned out that the other foundation design was more resource conserving overall. So there were a lot of different things that we looked at. Yeah, and the mention of no copper. Well, we've got copper. We don't have PVC.
We only have copper in wiring.
In the wiring, right. Yeah, so, and PEX, do you guys know what PEX is? Cross-linked polyethylene. It's a type of flexible supply piping for water. And it's, it was the subject of one of several really interesting studies that the U.S. Green Building Council did a number of years back when there was some pressure to prohibit the use of PVC in LEED buildings. And ultimately they decided they couldn't do that because when you looked at the use of PVC in terms of specific applications, in some applications it was less bad than some of the other options. In other cases, it was worse. And so they went, well, you know, we have to really think in terms of what application. And for freshwater supply, PEX, however, was superior to all the other options. That was another one of the analyses that we went through. So yeah, cut and fill. Yeah, pretty much every product was looked at through the lens of, is there an environmentally preferable alternative to this product? And that occurred throughout design and all the way through construction.
So
I have a question about the packs.
Mm-hmm.
Mm-hmm.
So have they resolved the extractable issue in packs?
What do you mean by the extractable issue?
Packs, you originally had extractable chemicals that got into your water.
Oh, well, yeah, I'm pretty sure that's been resolved because for a while it was approved by the state of California, then they withdrew that approval and it has now been approved again. So,
well, and actually it ended up being, I mean, truthfully, this is where politics comes into it. So there was a lot of pushback from the pipe fitters union because you don't need pipe fitters. You do for copper, but you don't for that. There's also was a lot of conversation about, because when you look at a traditional house, you have copper and copper then going into PVC, and there was some question about actually the copper and the PVC when you had hot water, the chemical reaction between those two and what that was creating. And I think with the PEX, the issue was somewhat about would it, you do have to protect the PEX because so we don't have it because it's subject to susceptible to UV. So, but all of ours is buried or in the walls. So
I use packs similar to packs when I built my house, and I end up having to put very large carbon filters to take those extractables out so it didn't taste like plastic water.
So was it cross-linked polyethylene or was it a predecessor product?
I believe it was cross-linked polyethylene.
Because the cross-linking is the thing that's supposed to make that
Exactly.
extremely stable.
It's supposed to lock everything out.
right, and that's been, and we did a lot of extensive testing.
Yeah, and I think to Linda's point too about the politics, the fact that the state of California has scrutinized it very heavily, in large part due to pressure from the labor community, means that if it gets through, we have probably the most stringent consumer laws anywhere in the country. So personally, I'm pretty much at rest with this issue.
Okay.
So we're just going to hit these 5 things, and then we're going to go into Q&A. So really, there's 5 key areas we talked about. So those what we just shared with you were kind of the overarching big picture things that we were going for. These are specific goals within the 5 areas of energy, water, waste, material, habitat. Energy, number 1, it's a net zero energy, net carbon house. So in essence, we have, it's also a fossil fuel free house. We don't even have natural gas piped onto the site. With green building, obviously your biggest thing is reduce, 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 and then power whatever you do have left in terms of a need for energy with an alternative source. So for us, we, in essence, have geothermal is one source of the alternative energy, and solar is the other source. And the house has, well, I'll just go to the next page because it's got the solar, but we've got, so net zero energy, fossil fuel free, and that includes all of our transportation. So one of the things is, so we have solar here and here, that's all we need to power the house. But we actually have enough solar. We think we're the first house, well, we haven't found any others, that the first house in the US that actually took into consideration putting enough solar on to power 5 electric vehicles. Now, our oldest child's only 13. We don't have 5 vehicles, and we don't have 5 electric vehicles. So what we did is we went ahead and put all the solar on anyway, so it's actually 118 panels, 21 kilowatts of power. We put it on because it allowed us to then offset any of the carbon from the actual construction, and it's allowing us to bank the carbon credits for our lifestyle. And so we believe that because our kids are young, that because we're giving all this free energy to PG&E now, that in essence we'll have built up a big enough bank to offset the carbon of our entire lifestyle.
So you are grid connected. Did you talk with the utility? Did you talk with PG&E about the effects on your local infrastructure for having that much solar feeding back?
What do you mean the effects?
Like your substations and.
Yeah, it's not enough to impact. It's not enough to have them create more substations but unless you mean helping them.
No, I mean, I don't know that much about it. I just would be a little concerned because I've heard that, in a neighborhood, if several people plug their electric vehicles in, that's going to pull too much power one way. And I would imagine that if you're having a really sunny day, you're producing so much power that maybe they haven't taken that into account for their already built infrastructure.
I haven't heard any concerns. Yeah, I haven't heard any concerns.
Are you kidding? They're intimately involved in this whole production.
Yeah.
And they want, this is their ideal. When Schwarzenegger signed the 1 Million Solar Homes initiative, that with 1 million solar homes in the state of California, we're an energy independent state. So PG&E is bring it on.
Yeah, and there's generally the concerns that are expressed about the grid and electric homes and electric vehicles doesn't really relate so much to the supply. Nobody's worried about an excess of supply.
Exactly.
What they're worried about is the timing of the supply versus demand piece. And so essentially they're being somewhat cautious in terms of, how much they want to see the adoption rate go up, how quickly they want to see it go up, because they actually don't understand what the full impacts are going to be on the grid as we go to an electric vehicle adoption, because of course all the input comes during the day and then the usage is spread out throughout 24 hours. So it's a little dicey.
I think the question was that if it produces too much power, will it burn something somewhere else? Is it? But current doesn't work like that unless the load draws that much power. Whatever, how much power you put in here, it won't go there. Somebody has to actually draw it.
Okay.
Yeah,
That's not quite what I was thinking.
No, but PG&E, obviously PG&E is intimately involved. They're especially with any of these greenhouses that are putting a lot of load on, because they want to learn from it. So we actually have people at the executive level at PG&E who have been monitoring our house, again, as a demonstration site. So they have no challenges at all. In fact, they love it because they think we're energy philanthropists, because they don't pay us for the extra energy that we're producing. So more things on energy. Obviously, we have the wireless, the AV control system. For those of you who asked about the monitoring and the management, this is kind of a lot of Control 4 really handles all of that. On the lighting, we use no lights unless it's dark. If you come to our house, you'll see it's all glazing. We use 100% LED or CFLs, and one of the coolest things is that we use, even with all the lights fully on, we use less than 1 watt per square foot. The materials, there's only 4 materials in the house. It's very simple. It's wood. There are 5 species of, in the sources of wood, there's only 5 species of FSC certified wood, recycled or reclaimed wood, which is the barn wood that's on the floor, and then salvaged wood. And we're trying to demonstrate good salvage versus bad salvage. So good salvage is, there's a freeway going in, instead of just mulching it up, there are people that'll take it off, they'll take big pieces of it and they'll save it, versus bad salvage, which is you take a giant redwood out of the ecosystem, which can house up to 1 billion organisms. So we want to try to avoid that type of salvage. Metal, we used all recycled metal. It's harder to show this when we're here. One of our goals with stone was we use no newly quarried stone. So the stone is either out of the bone pile in Texas, it wasn't good enough for somebody else's job, or we have this big stone on site that was actually quarried 50 years ago for a building in a stadium. There's 40 acres of it that never got built. And the one thing is you can't put it back. So it really is trying to demonstrate how much waste there is in the green buildings. And then obviously glass is all recycled. Again, no painted surfaces. We in a couple of places where we have color. Again, one of our big things is, as a demonstration site, we tried to showcase things that, even though it didn't really matter for us, we were happy to live in an all wood house with no stain or color or anything, but other people might want color, so we wanted to showcase a way to have color in a sustainable way in a house. So we used plaster with integrated color. Same thing with air conditioning. We don't need air conditioning, but we have radiant heating, which can also do radiant cooling. And water. Anne, you want to talk about water?
So yeah, Linda mentioned earlier that the large energy burden that water represents. Does anybody know what percentage of the state's energy is used in some way, shape, or form related to water? 1 digit, 2 digits?
30-some-odd%.
It's actually 19. But it's a big number. It's a really big number. And so obviously a relatively small fraction of that is actually related to residential use. Nevertheless, we're concerned about water for water's sake as well as for the sake of energy. And so we look at both. And so one of the very, very unusual aspects of this project is that all of the gray and black water is captured and treated and used on site. So, and this is, Linda could probably speak to the bureaucratic battles associated with that process at great length. It is not used for potable use, although it is of potable quality. But because of various health regulations, we're restricted to using it primarily for subsurface irrigation. Could have been used for toilet flushing, but the extra materials, the embodied energy that would have gone into a secondary system for flushing toilets with the water made no sense in a system where all the water was already being captured, processed, and reused.
And they make you put chlorine in it in case that toddler drinks out of that toilet. So wasn't worth it.
Right.
That's
yeah.
seriously why they
Yeah,
do
the
it.
embodied energy, right, and the other chemical inputs. And so it's like one of those on balance, the conventional wisdom is, oh, well, you should definitely use gray water for flushing toilets. Well, this, and it's also a great illustration how every project, it's kind of where Linda started, that you start from your own agenda and your priorities, themes, however you want to apply them. And so, for example, the story about the 6-month floor design project arose out of the fact that 2 of Linda's kids have respiratory issues. And so there was a desire to have 0 chemicals of any dubious nature in the house. And the sort of normal approach to doing radiant floor system uses composite engineered wood panels that the radiant tubes are embedded in. Well, turns out those engineered wood panels have questionable chemicals in them. And the very, very typical dodge that you get from product manufacturers is when you ask, so what is in that product? And they say, give you a very detailed sheet, 5, 6, 8 pages of fine print on an MSDS, material safety data sheet. Are you guys familiar with those? Have you run across them yet? Okay. But somewhere in the fine print, you'll see X% proprietary product. And you say, so about that proprietary product, what is that? And they say, oh, we can't tell you that. It's like, well, sorry, we can't buy it. So anyway, that was what drove the floor system. That's what drove things like, no, we're not going to use gray water to flush the toilets with and end up with chlorine in the system, which has some adverse health concerns.
So one of the things that Leslie talked about that she learned from another thing is that we had a permaculturist work with us, and the goal is really repurpose a drop of water 4 times. So again, I've got pictures up here if anybody wants them, but this is actually the picture. We have a 50,000 gallon cistern. We actually designed the house as a 1-story house with a steel roof. The steel roof is made of 85% recycled material, and it's 100% recyclable on the back end, and it's a 100-year roof with no maintenance. So from a durability is a big deal in green building as well. So this is actually part of the gray water and black water, but this, it looks like an ICBM missile. Seriously, it's huge. You can't, it's buried now, but we could actually become the municipal water source in an earthquake. So we are across the street from the San Andreas. So water is a big deal. Obviously, we use all the normal things: low flow toilets, low flow everything. All right, escape. So I don't know why, Ann, it works for you and it doesn't want to work for me.
It likes me.
It does. Sorry, you guys. This is something about this system because it doesn't, I've done this 1,000 times.
Comes the rescue guy.
Never done it. So what are you hitting?
We just hit Command
Yeah.
Tab and then
Oh,
select
Command Tab.
Adobe.
Adobe. I don't know why it's doing that. Okay, so the other thing, there's the cistern there. So again, obviously, the whole landscape is also completely native. So as we talked about, we use Delta bluegrass, we use the native grasses. In addition, back in behind the house, we've actually gone as far back as when the Ohlone were here, and we've used a meadow restoration consultant to try to actually restore that meadow as if it were 200 years ago. So the other things are native to California, but those grasses are actually native to the site. Waste, we talked about, obviously we have recycling, we have composting on site, we do have chickens, so you can come see our chickens. And Ann talked about that 100% of the wastewater. The habitat is, the only other thing I'll say about habitat, which is cool, is that we have 5 field biologists. As I said, they chronicled, and you can see it here, all the native flora, all the native fauna, and then they cross-reference the habitat value of the native flora for the native fauna to actually create our landscape, because we wanted to invite the wildlife in. So we're studying bats, amphibians, mammals, birds, and reptiles. And we have bogs that are, in essence, supporting wildlife on site that are around the pool. And so we studied it before, we studied it during construction, and we're going to do a 10-year longitudinal study. So one of the things that we're trying to do is actually do what we said we were going to do and make sure that the house is actually operating accordingly. So these are all biofiltered there. Obviously, we've gotten a lot of visibility, which has been great. But our real goal here is for it to have an impact. and for people to learn from it and to give it away. So we've had, as we said, we've hosted tons of events. We've had field trips. I've taught, guest lectured on site again for STS and some other places at Stanford besides the Graduate School of Engineering, because it really doesn't matter. Like, that one house isn't going to matter unless hopefully you guys take something, you learn something, and you do something with the knowledge, or you share it with someone else. Or you can, our kids founded an organization called the Earth Savers Club for Kids. You can go to their website and give it to little kids that you know. So really it's more about kind of what we do with it, and we hope that it'll be kind of that pebble in a pond that will have a ripple effect. So with that, I'm going to just shoot through there. We do have the website is up. It's www.Tah.Mah.Lah.com, Tah.Mah.Lah, and .com. It hasn't been up before. We literally just launched it. As I said, the USGBC tour is coming, and on the 16th, and any of you are welcome to kind of just sneak into that tour. Everybody else will be paying for it, not to us. They're paying for Greenbuild. But happy to come, or if anybody has any other questions. I've been mentoring a lot of people at Stanford and having them come and giving them access to all the people on the team. So we're always happy to help people from that perspective. But with that, let's open it up for any questions. There were a number of them on here.
Yeah, you guys had some. Actually, while you're sort of reconsidering those questions, one thing I wanted to talk about right away is that the cost element, because this does always come up. And it's embedded in a number of the questions that you guys sent us. And I think it's really important to remember, so when we talk about green building, as I said, at core, we're talking about change of the status quo. So you go from product X to product Y. And in going from X to Y, there are actually 3 cost elements, and they're often lumped together in the case of green buildings. And I think that's wrong-headed. And so I like to take any opportunity to debunk those myths. So the first cost element is a learning curve cost. So I alluded to that before. Okay, so learning curve. So this doesn't have anything to do with the building, right? It enables the building to be built. But fundamentally, this cost should be absorbed by the folks who are going to benefit most from the learning, which isn't the homeowner. It's all the professionals who are building their capacity as professionals to deliver a more sophisticated, relevant product. So this is not about the house. The second cost is the other one that Linda referred to, and I'd call that kind of the green increment, or the bump in quality, where you start in saying, okay, so let's do green. Well, what does that mean? Oh, well, maybe we should have a more durable roof, for example, because all of a sudden we learn through this process that durability matters, longevity. If you take a building and you make it last 100 years instead of 50, well, then you've cut the material impacts in half. So that's an increment, and that's based on a decision to produce a different product. So you can't really blame that on the house either. You've, in effect, changed your goal. You've shifted your goal. So it's no longer an added cost. It simply becomes part of the cost of this new product that you've decided to create. And the third cost is administrative. So, and this is if you go after a certification of some sort. So there's some administrative cost to doing that. And actually, I could break this down a little bit too, and talk about a little bit about quality management too. So administration, yeah, people have to collect fees to run programs. And quality management is something that's almost entirely lacking in residential construction. And so there are people through green programs who come and say, did you do all those things that you said you were going to do, and are they actually functioning? In the commercial building world, we call it commissioning. So of the 3 costs, this one is relatively minor. Doesn't add a lot, and it does add a lot of value because it contributes to the functioning of the project. There are so many buildings that are built never function as they were intended. It's because nobody catches it. This is because you decided to create a different product. So that's going, well, perhaps I will buy a Beamer instead of a Hyundai. Well, that's not the Beamer's fault, right? That's because you changed your mind about what you're going to spend your money on. And learning curve is professional development. So anyway, that's my little homily on cost. Questions? Sorry, and we have 3 minutes. That's terrible.
Five.
We've talked too much.
So what else? Hopefully we looked at your questions ahead of time, so we're trying to hit them as we're going. So do you guys have other questions? There's a lot of questions about LEED. Did any of you guys write those questions?
Are they burning? Yes.
So my question is actually like talking about the myths. You're trying to debunk the myths. I mean, you can debunk the myths until people start using, like having the green buildings, using some of the appliances that we're talking about. What are you doing on the marketing aspect? What are you doing in terms of like spreading this message to people? And is it working? Are people changing their behavior?
Well, we're here.
Yeah, I mean, certainly yes. I mean, we've helped a lot of people. So for instance, we have worked closely with the town of Portola Valley. Town of Portola Valley has now implemented very, very stringent green building code. So that helps, but they also have us as an example to demonstrate to people that that isn't the end of the world for people if they do that, because obviously there'd be people that push back. You know, so it runs the gamut of where people are on the spectrum in terms of what they're looking for. Obviously for the startups, there's huge visibility for the startups in that sense. I mean, we've had a lot of press on the house because it's won a lot of awards, it's gotten a lot of visibility from that perspective. And, you know, we continue to do events and host events for people. And it could be everything from, you know, doing music outreach and using the house as an excuse for people to want to come hear a concert to pay for music in schools, to Sustainable Silicon Valley wanting to use it specifically because these 5 mayors are working on green building code. So the outreach is really getting the website up so that we can send people to it, so I'm not constantly having to write emails to people. But that's one. But the 2 is continuing to host events, which we've been more than willing to do. The Solar Decathlon team, I mean, there are 30 kids on that team. And we have opened, our entire team has been working with them to kind of, this is the first time Stanford's ever been accepted into the Solar Decathlon. So we're all very excited for them. So we hope it really goes well. You know, we've been mentoring people in the D School who have been looking at different places. So it is kind of a word of mouth, because the challenge is we don't want it to be about us. We want it to be about the house. And obviously we have a lot of connections, but then it becomes about us, and that doesn't help, that doesn't promote. So really what we're trying to do is do some outreach and put it out there, but then also have it be kind of word of mouth as it goes along. And also having people come and be in the space. I mean, honestly, truthfully, this is a very hard class to do. It's very flat for us to come here and have this conversation. It is far more fun and far more dynamic. I will just say to Leslie now, to have you guys there, walking through the house, seeing the cistern, climbing up the ladder into the loft, the play loft, and being in Narnia, which is what the girls call it. So I mean, it's just a more dynamic 3D experience than anything that we can convey here. So I think it's easier for you to walk away interested, excited, inspired when you're actually there and you're saying, ooh, you know what, I want to do this, or I want to tell somebody about this, than it is when you see it.
This on the 16th, so.
Yeah, you can do it on the 16th. I'm just saying that I think that we try as much as we can to bring people to the site, because we think that actually tells the story better than anything. We had it was the site for the the International Association of Landscape Designers. They do this, they had their international conference in San Francisco, and we had people who came up and said, look, I've been going to this conference all over the world for 10 years. I've never been someplace like this. So that's really what we hope, is people walk away excited.
So was your question also more broadly about green building as a whole? Yeah.
Yeah, I mean, that's LEED, and those guys have been.
Yeah, I mean, I'd say I've been involved. I've been in green building pretty much 24/7 for the last 20 years. And at the time, it wasn't called green building. Nobody knew what it was. And now it's pretty much a household word.
Right.
So I think we're making good progress.
You had a question?
Yeah, you talked about looking at the chemicals in different products you used. How in depth did you look into the solar panels? Because I know a lot of the issue, or a lot of things that are brought up about solar panels, is the embedded energy that goes into making them. Was that a factor in your analysis?
So
go ahead.
Well, the embodied energy in solar panels is generally paid back within the first 3 years of operation. So that's the simple answer. In terms of the actual manufacture, the chemicals piece, they are what they are. But as Linda said at one point too, energy trumps. Right now, because climate change issues are so paramount to the successful proliferation or survival of our species on this planet. The planet will be fine without us, but we'd like to stick around. Therefore, we tend to prioritize energy issues over others when we have to make trade-offs. And so, yes, there are chemicals that are not benign that are used in the manufacture of photovoltaics, but the net effect from an energy perspective offsets so much carbon that there's really no choice. We have to adopt
Rumsey Engineers
renewable energy.
was Rumsey, who did Y2E2 and have done a lot of the green buildings on campus. That's who our our MEP was Rumsey. So, and they just drilled it. Energy, energy, energy. It trumped everything.
Now that you've been living in the house for a little bit, is there anything that went exceptionally well or anything that you would have changed now that you've lived in it?
It's funny, everybody asks that question, and I have to say, so we've been in it a year, and there is right now nothing that we would change. It's actually functioned phenomenally well, but that's why I think this concept of integrated design, but also starting with what your themes. What we didn't start with was we needed 5 bedrooms and 2 bathrooms and a this and a that. We started with, here are the 5 themes that really we care about, and whatever you build, if you look at those, and every single person on the team had to read that, and if they thought it was too hokey, then they didn't join the team. And so I have to say it's really functioned for all the inhabitants and for the people who have come. It's functioned really well. I mean, there's been some commissioning things. I mean, one of the things that I think is really, really important in anything you do, I don't care if you build a new product, you start a company, but the minute you launch, you are not finished. And so that's one of the things that I think a lot of people miss. And I think that's to me, the biggest criticism I have of LEED is that we got our LEED Platinum, highest rated house, blah, 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 the second we walked in the door. Living Building Challenge, we can't even start that process till now for a year later until you've actually seen the house work. So I think there's a lot of people who potentially are getting away with a lot of stuff because nobody monitors it or maintains it, and you get to keep your status in perpetuity without anybody ever coming back and checking up and seeing if you actually did what you said you were going to do, or if it's performing that way.
Yeah, although in the commercial realm, you guys may have heard that there's LEED EBOM, existing buildings, operations and maintenance. So the vast majority of buildings that get a LEED rating as a new building will typically go on to get the EBOM rating. So they are addressing that. For homes, it's a little bit harder because a homeowner, isn't selling anything. And the point of getting a rating before there's operational data is the rating, originally the idea is to help a builder sell a product. So there are folks like Linda and Paul who wanted the rating for other reasons, as she described to you. But from a mass market perspective, it's all about, Better Homes and Gardens, Green Homes and Gardens seal of approval, so that as a buyer you can go, oh, this building was built with a higher set of considerations. And so that precludes having operational data. That said, there are diagnostic and performance checks that are done on all LEED homes, and it was designed with that in mind. The understanding that we can't wait until a year after it's been sold to put a rating on it, or it defeats the purpose of the label.
Yeah, because remember, LEED for homes was
to
actually not designed for people like us. It was designed for KB homes and all the people who are doing production homes, right? To try to get them to do it.
Right, because those are the people who are producing the vast majority of all homes, and getting them to do things better is tremendously important.
Right.
The one house demonstration project serves a very different function in the ecosystem of green than those mass market buyers or producers, rather. So.
Kind of over time.
Are
you willing to hang around?
Yeah, we'll stick in. We've got pictures and things like that if anybody wants it, and you can email us through the website too if you have any questions.
Thank you
so
much.